Now we're going to be putting a lot of the things that we've been working on together. So we started with being able to make a graph, and that's what we're asking you for. So the independent variable, remember that's what goes on the x-axis. It can stand alone. So that's going to be time watching TV. And that means the dependent variable would be the grade. And that would mean it's in a percent. The relationship between the two variables. So we always look at the independent variable and say as the independent variable increases, but instead of saying independent variable, so as time watching TV goes up, then we talk about what happens to the grade. As time watching TV goes up, or you could say increases, that sounds really smart, the grade goes down or decreases. And that's just really, that relationship is what happens as my independent variable goes up, what happens to my dependent variable. So then, again, it's important that we define our variables. So this is going to be that time watching TV. And y is the grade. And that just helps us to put whatever we're doing in context of the problem. So to calculate the slope, we need to come up with 2 points on our line. Let's see. Looks like I can go here at 16 and read across. And that is going to be, this line here would be 10, so it's a little bit below 10. I'm going to guess at a 7. So 16, 7 is one of my points. And then I want a second point. Remember, I want to keep it at a distance. I'm going to do 6. I don't want to do 4 because that point is there, and that's going to mess up whatever I'm thinking. And here, so I kind of have to estimate that point. I know it's going to be, I know this x value is going to be 6. And I'm kind of in my head debating between 57 and 58. I'm just going to pick 58 and go with it. I know that that's an estimate. I know it can make a difference. As long as we are keeping our 2 points further apart, our y-intercept should still match up when we're writing that. So my slope, remember, that's y2 minus y1 over x2 minus x1. So if I want to label my points, I can. So 58 minus 7 over 6 minus 16. And then I get 51 over negative 10. And then I'm going to put that as a decimal, which would be negative 5.1. So I can compare that to my graph, and I can see that my slope is going down to my graph. So it gives me a good indicator of kind of what's happening. I also could look at a couple different points to see, is it actually going down by about 5? Remember, if I go from 6 to 8, that's going down about 2. And if I look, it does look like that is going down by around 10. So twice my initial slope. So that looks pretty good. And then it says write an equation using point slope form. So this is where I'm just going to pick one of those 2 points. So we did point slope form yesterday. And this is y minus y1 equals m times x minus x1. I'm going to use my first point just because they are labeled x1, y1. So y minus 7 is equal to negative 5.1 times x minus 16. And now number 7 is saying convert that. So y minus 7 would stay. And then I'm going to multiply this negative 5.1, negative 5.1x. A negative times a negative is a positive. And that one I need a calculator for, plus 81.6. And then I have to add a 7 to both sides. Then I like to compare my y-intercept with the graph. So my y-intercept here is 88.6. And I want to look to see where my line here would cross. And if I moved it up, that seems pretty accurate to me. So that's the second place that we can check the accuracy. The first is the slope, and the second would be our that y-intercept. And that's going to be something I'm going to ask you on the summative, is about the accuracy of your graph. And it has to do with comparing the calculated to your actual line of best fit. So it says, using your equation, make a prediction of the grade if you watch TV for 5 hours a week. So remember, watching TV, that's going to be our x variable. So I know that x equals 5. I'm just going to replace my x in this equation with a 5. So negative 5.1 times 5 plus 88.6. And then I just type that into a calculator. So negative 25.5 plus 88.6. And I get 63.1 would be the percent that I would expect. Using your equation, make a prediction of how many hours of TV you watch given a grade of 40%. So that means that 40% is that y equals 40. So I get 40 equals negative 5.1x plus 88.6. So we're back to solving equations. My goal is to get x by itself, so I'm going to start with subtracting the 88.6. So negative 48.6 equals negative 5.1x. To get x by itself, I'm going to divide by the coefficient. And I get x equals 9.53, and those would be hours. And then now we just have another graph. So you're just going to try out the other graph and then check your answers on the module and see how you did.